Okay, Algebra 2, we're moving into the second half of Chapter 5 now, and in pursuit of what we're eventually going to be doing right here, which is solving polynomial equations with a little bit more independence than some of the more complex ones than we've been doing so far, we're going to get into a concept right here called dividing polynomials, and we're going to break that down into two categories. The first one right here is called polynomial long division, and if that name scares you a little bit, I wouldn't be surprised, because a lot of us were really, really bad at regular long division the last time we covered that, which might have been, I don't know, 5th or 6th grade. So humor me for just a second, guys, and let's talk about a problem here. I'm going to make something up here. I'm going to go with 376. Let's go with that. And we're going to divide that number by 5. And we're going to take just a minute here to review how we did long division back in the day. We usually wrote long division with this little symbol here, and I think my 4th grade teacher called that the garage. This number right here, the number we're dividing by, is called our divisor, and that number goes outside in that spot right there. The first number, which is usually the larger number of the two, but not always, that one is called the dividend, and that's the number that my teacher told me to put in the garage, like that. So we're taking 376 and dividing it by 5. So the way I was taught division, and that's not necessarily the right way, but most people have seen some variation on this theme before, you ask yourself first if this 5 divides evenly into that 3, or if it goes in there at all, and the answer in this case is no. 5 doesn't go into 3 at all. So what we do is we kind of expand that 3, and we look now with the next digit there at the number 37. And we ask ourselves, how many times does 5 go into 37? And the answer to that is going to be 7 times. We then multiplied this 7 times this 5 here to get 35. We write that number underneath the 37, and we subtract now the 35 from the 37. That gives us a 2 down here at the bottom. Next, we bring the 6 here, the last digit of the dividend. We bring that down here, and we now get a 26 on the bottom. Okay, so we look at our divisor, which is 5, this number here, which is 26, and we say, okay, how many times does 5 go into 26? 5 times. So we put that 5 above the 6, and again, we multiply down. This 5 times this 5 is going to give us a 25 down here on the bottom. And again, we draw a line here and we subtract. 26 minus 25 is 1. Now at this point, there are no more digits in the dividend to bring down. So we have a couple of different ways we could handle this. Once you got a little bit further along in division, you learn to, don't do this guys, you learn to put a decimal point here and a 0, and then bring the 0 down, and 5 into that 10 would go 2 times. So your answer expressed as a decimal was 75.2, and that's where this one would end because your remainder now would end up being 0. However, let me take you back a little bit further than that. At this point, when you guys first learned division, this number right here that sometimes is there left over is called your remainder. And the first thing you guys learned how to do with a remainder is simply to put the little letter R right there and then a 1 at the end. Okay, so your quotient here, your answer would be 75 remainder 1. I bring that up because there's something we were going to do with that a little bit later that's a little similar to what we're doing now. A third thing you learn to do, and actually this is probably the one I should show you, is to take that remainder and express your answer as a fraction. That remainder 1 becomes the numerator of your fraction, and the denominator of your fraction is your divisor right here, which is 5. So 75 and 1/5 is another way to write that. So let me see, guys. We came up with 75.2. We came up with 75 and 1/5, and then 75 remainder 1. Those are all 3 equivalent ways, really, of expressing the answer. The first 2 are a little bit more useful than the second one, and actually this is the one we're going to be focusing on today. Okay, so that was just a crash course in how to do numerical long division. Let's talk about what it looks like with polynomials. And this looks really, really scary here, guys, but we're going to try to break it down and just go step by step through this. We have a quadratic trinomial here, 21x squared minus 43x plus 20, divided by a linear binomial, 3x minus 4. So just like I did back in 4th grade, I'm going to make this garage right here. And the term, the polynomial, I should say, we are dividing by, that is our divisor, goes outside here. There's where 3x minus 4 goes. And then the polynomial that, again, is normally larger, the one that is being divided by the divisor, that's our dividend, that goes underneath the garage. So that's 21x squared minus 43x and a plus 20 at the end of all that. And I know this looks very, very different, but we're really going to be following the same pattern here that we did when we were dividing, what was it, 376 divided by 5. What we're going to do now is not focus on everything, but we're just going to look at this term right here, the first term of the dividend, and this term right here, the first term of the divisor. And the question is going to be here, guys, what can we multiply by 3x to make it become 21x squared? And I'm hoping you can look at that pretty quickly and tell me that the answer there is going to be 7x. 3x times 7x would get us 21x squared. So 7x is going to be the first term in our answer, in our quotient, and I'm going to write it up on top. Now, a lot of people want to put it right here because they think, ooh, that's the first spot. But it actually makes more sense to put it right over here. And if you're asking yourself why, because I want to line up these two like terms right here, the 7x and the 43x. I think that's going to help you know when you're done with a problem like this. Now here comes the fun part. We're going to take this 7x that we just wrote up on the top, and we're going to multiply it by this entire binomial here of 3x minus 4, and we're going to write that result on the next line right down here. So what we're basically doing here, guys, is a mental distributive property. 7x gets multiplied by 3x to make 21x squared, which it should. That's why we chose the 7x. But we also then have to multiply the 7x times this minus 4 right here to get a minus 28x. Okay, so that's the product now of 7x times the 3x minus 4. And what we do now, guys, there's a little phrase that the teacher I student taught me, and that phrase here is this: draw the line and change the signs. Because we're subtracting, we change the sign of 21x squared to a minus 21x squared, and the negative 28x is now going to become a plus 28x. And that's because, just like we did on this step right here, you subtract that 35 from the 37 above it. The 7 times 5 gave me 35, but then I had to subtract it. So the subtraction is the reason we change these signs. And now we add like terms vertically. 21x squared minus 21x squared, those terms cancel out. And guys, that will happen every single time we do polynomial long division. If it doesn't, you made a mistake somewhere along the way and you need to go back and fix it. Then we've got a negative 43x plus 28x. That's going to give us a minus 15x. Okay, so step number 1 here is done. And the next thing we're going to do, if you remember what we did after we came up with this 2 right here, we brought that 6 down to turn that 2 into a 26, and then kind of started the process all over again. Same exact thing happens right here, guys. We're going to bring this plus 20 right there and put that at the end of the minus 15x. And now the process starts all over again. Now we look at the 3x out here and the negative 15x right here. And we ask ourselves, what do we need to multiply by 3x to make it turn into a negative 15x? And the answer to that, I'm hoping you see quick and easy, is going to be a minus 5. Notice again, 2 like terms lined up vertically. 5 and 20 are both constants. Okay, so we're going to multiply down, but remember, guys, this number isn't a 5, it's actually a negative 5. So negative 5 gets multiplied by that 3x to make a negative 15x. And then the negative 5 gets multiplied by the negative 4 to make a positive 20. Now that phrase was draw the line, here we go, and then change the sign. The minus 15x now becomes plus 15x, and the plus 20 now becomes a negative 20. And we add vertically here, and what happens? Negative 15x plus 15x, those terms cancel. Positive 20 plus a negative 20, those terms cancel, and we end up with 0 here for our remainder. And if you remember this about numerical long division back in the day, a remainder of 0 is really the best thing that you wanted. You could have seen, guys. That means that this big messy polynomial right here divides evenly by 3x minus 4. So this right here, you guys, 7x minus 5 is our answer. Now, if I wanted to check that, guys, this is something your 4th grade teacher might have taught you, you can always go back and multiply your quotient, which here was 7x minus 5, by your divisor, which was 3x minus 4. And if we've done this right, we should get back to the original dividend right here. So binomial times binomial, I would check that with FOIL. 7x times 3x is a 21x squared. My outer product there is a minus 28x. My inner product there is a minus 15x, and my last product, negative 5 times negative 4, is a plus 20. As is usually the case, those two terms would combine to a negative 43x, so I've got 21x squared minus 43x plus 20. That's exactly what my original dividend was equal to. So that's a little trip down memory lane there to how you check your answer to a long division problem. Okay, guys, that's what polynomial long division looks like. And I wouldn't think you guys would feel like you totally understand it after just one example, so I've got one more that I want to do with you guys, but you're going to need to practice this skill quite a bit on your own to get the hang of it here truly. Let's take a look at this one right here. 2x cubed minus 47x plus 3 is being divided by x minus 5. And I just kind of gave you a little alternate wording right here. You might see a problem worded this way. Is x minus 5 a factor of 2x cubed minus 47x plus 3? What that question is basically asking is, does this division problem work out evenly? Now, in the last problem we did, if I had asked you, is 3x minus 4 a factor of this polynomial, the answer would have been yes, because of the fact that your remainder was equal to 0. Now, if that remainder was anything other than 0, let's say a 5 or a negative 3, then the answer would have been no. So let's see where this one gets us. Okay, we're going to begin with x minus 5, which is our divisor. That's going to go outside the garage. And now when we get here, there's a little wrinkle in this problem that I've got to prep you guys for. What's going on right here is I'm going to write my dividend here, starting with the 2x cubed, but right away we've got a little bit of a problem. The next term is minus 47x. You may have noticed here, guys, that one of the terms in that expansion there is missing. There is no x squared term right there, and that's a problem for us. So if they're ever missing a term, we have to include it here. So I'm going to put a plus 0 x squared. You'll see why I had to do that in just a second, guys. Now, other than that, I'm going to go then in order with a minus 47x and then a plus 3. But you can't skip any terms in your dividend here when you're writing it in polynomial long division. I'm going to slide that a little bit over to the left. I think I'm going to need that room. Okay, guys, let's get started. The question now is, what do we need to multiply by x to make it become 2x cubed? And the answer to that is a 2x squared. I'm going to write that above the x squared term so that like terms line up. 2x squared. And let me multiply down now. 2x squared times x is 2x cubed. And again, I'm lining up like terms. And then a 2x squared times a negative 5 is minus 10x squared. Now, I'm going to put that here underneath the other x squared term. But guys, if I hadn't put that 0x squared term right there, we'd be a little bit lost right now for where to put the 10x squared, because everything else over here would have been right there. And now like terms don't line up, and this gets really confusing when you go to try to do subtraction. So that's the reason why it's important that you put zeros in there in case you're missing any terms. Okay, here comes the fun part now. Draw the line and change the signs. The first term becomes negative. The second term is going to become positive. 2x cubed minus 2x cubed, those cancel like they always should. And then adding up the next column, I'm going to get a positive 10x squared. Okay, cool. At this point, we bring down the next term here, just the next one, not both of them. A minus 47x is going to come straight down. And now we start all over again, asking ourselves, what do we need to multiply by x to make it become 10x squared? And the answer to that is 10x. And since it's positive, we'll put a plus here, and a 10x goes above the negative 47x. And let's multiply down now. 10x times x is going to be 10x squared. And 10x times a minus 5 is minus 50x. Got it. Draw the line, change the signs. Now a minus, and this term becomes a plus, and let's combine. 10x squared and a minus 10x squared, they cancel out like they always should. Negative 47x plus 50x is going to give us 3x. Okay, making good progress. We have one more term now to bring down. We didn't have this in the last problem, but here we go. So there's a plus 3 that comes at the end of all that. And we ask ourselves, what can we multiply by x to make it become 3x? And that answer is going to be a positive 3. That'll go right there. And let's multiply down. 3 times x is 3x, and then 3 times that minus 5 there is going to be a minus 15. One more time, we draw the line and we change the signs. The 3x becomes a minus, the negative 15 becomes a plus, and let's combine our like terms. 3x minus 3x, they cancel. Plus 3 plus 15 is going to give us an 18. Now you'll notice here, everybody, there is nothing left to bring down here anymore. We're done with that. We've used all the terms of the original dividend, and unlike the last problem, we did not end up with a remainder of 0. We got a remainder here of 18. So the way we're going to handle our remainders at this level, everybody, is the fraction way that I showed you how to do in this problem right here, where we took this and made it 75 and 1/5. I just want to remind you guys of something we may have forgotten and maybe we never knew. A mixed number like 75 and 1/5 is really an addition expression. 75 and 1/5 really means 75 plus 1/5. And I bring that up because that's exactly what we're going to do right here. Our remainder is 18. That needs to get added as a fraction at the end of this polynomial here. So the 18, the remainder, becomes the numerator of that fraction. And then the original divisor, x minus 5, becomes the denominator. And I know it's messy, you guys, and this is a format we're not used to, but this weird-looking polynomial expression here is our quotient. Okay, so we do end up then, guys, with some quotients that are going to have remainders in there as well. And so that's how we handle it. But don't forget to put that plus sign right there. If this had ended up being a negative 18, probably would have been easier to put a minus sign right there. But anyway, that's how we handle a problem like that. Let me undo that, and that's where we sit. So that's what polynomial long division looks like. Loads of fun. I'm sure you're excited. Now, excuse me, if that looks complicated to you guys, I have good news for you. There's a faster shortcut method that's a little bit weird at first, but once you get the hang of it, which isn't going to take you very long, is going to work much, much faster than what we did in this problem right here. The catch is, guys, it's only applicable in certain circumstances. So the next thing we're going to talk about, so number 1 in our notes, we called polynomial long division. There we go. And now we're moving into something called synthetic division. Now, what I want you to notice here, there's a reason for it. I'm giving you the exact same problem here again that we just did. 2x cubed minus 47x plus 3 divided by x minus 5. And let me ruin the suspense for you. We're going to get the exact same answer again, but we're going to get it in a different way, and I want you guys to see how this works. However, I've got to warn you about something here. Synthetic division is a cool method right here, but it only works in certain cases right here. So we're going to go ahead and write this out. If it only works if divisor is a linear polynomial. Now in this case, x minus 5 is a linear function, but if that was an x squared minus 5, now that's no longer linear. That's now quadratic, and this wouldn't work. So this only works if your divisor is linear, and this is important right here. If it's a linear function, then really the number I'm talking about right here, the coefficient of x, that's really the slope of your linear function. If that slope is 1, that is when synthetic division works. So in this case, we have x minus 5, and that's a 1x really right there. This is a case where synthetic division will work. Now, just for the sake of argument, if that had been an 8x minus 5, synthetic division would not work in this case. So if we go back to the very first problem we did, Our divisor was linear, 3x minus 4, but the slope there was 3, not 1. So we cannot go back and do this problem again with synthetic division, but we could go back and redo this one before I messed it all up. So, okay, that's what we're looking at here, guys. So we're going to do the exact same problem again, which works here because we're dividing by a linear function with a slope of 1. Let me show you what this looks like. We start off by drawing a box, although for some reason we always only draw two sides of the box. If you want to go ahead and draw the rest of it, you're perfectly welcome to. And then, this is something that always gets people, we're going to take the opposite of this number right here. So since that's a negative 5, we're going to put a positive 5 in the box. So you've got to remember to change that sign. Then, after the 5, but on the same line, I'm going to put all the coefficients of the original dividend, just the coefficients. So I'm going to start with a 2. You don't need to write the x cubed. Now, once again, the x squared is missing, so I need to put a 0 right there in the place of the x squared term. Then I've got a negative 47, don't forget your negatives, and then a positive 3 at the end of all that. Okay, and what we do now is we skip a line, and then we draw a line underneath on the bottom right here. But notice I left that space underneath. And now here's where we begin the process of synthetic division. First step is really easy. Whatever this number is here, we're going to bring it straight down to the bottom, and we'll put that 2 right there. Now, here's where we start to do some fun stuff. We are going to multiply the number that's in the box by this number down here on the bottom. The 5 times 2 is going to give us a 10. And then we write that product, 10, in the next spot in the bottom. In this case, underneath the 0. And then what we're going to do is we're going to add these two numbers together. All right, so the 0 plus 10 is going to give us a 10 for this number right down here on the bottom underneath in that second column. And now, this gets a little bit crazy if I keep drawing arrows. We do the same process all over again. We multiply this 5 right here by this 10. The 5 times 10 is going to give us 50. That result goes right over here. And then we add these numbers together here. The 47 plus that 50 here is going to give us a 3. And one more time now, we multiply the 5 times the 3 here, and we get 15. That number goes right here. And then we add these two numbers together as well. The 3 plus 15 gives us an 18. Now, there's nowhere further to go with this. That's it as far as the synthetic division goes. And so that doesn't really seem to have accomplished very much, but now I need to tell you guys what to do with your answer right here. We started off with a cubic polynomial, 2x to the third, and we divided now by x to the first. So what we have right here, guys, is the coefficient of the first term in our quotient, and the degree of that term is going to be 1 less than what we started with. Since we started with x cubed, this is going to be 2x squared. What's next? We have a positive 10 for our next term, so we're going to put a plus 10 now, and again, the degree of each term just goes down by 1. This was x squared, so this term is just an x. What's next? A positive 3, so we're going to put a plus 3, and let's see, we had x squared, x to the first, then this term doesn't get an x. That's just your constant right there, plus 3. And then this number right here, you guys, is going to be your remainder. So just like we did on the last problem, we put a plus here and a fraction. The remainder goes in the numerator, 18, and then the original divisor, x minus 5, is the denominator. And that, everybody, you should notice right here, if we did this right, should be the exact same quotient we came up with on the previous slide of 2x squared plus 10x plus 3 plus 18 over x minus 5. Now, I'll leave it up to you guys to determine which of these two methods you like better and which one you think is easier. Just about everybody, once they get the hang of it, agrees that synthetic division is faster. So again, I want to remind you guys of this little warning right up here. Synthetic division only works if your divisor here is linear, all right, so no x squareds or x cubed, but just x, and if the slope of that linear function is equal to positive 1. So that's how that one works. So let's try this one now. A little bit more complicated. X to the fourth plus 6x cubed plus 40x minus 33, and we're going to divide all that by x plus 7. And again, here's that alternate wording. Is x plus 7 a factor of that big, what is that, a 4-term quartic polynomial? Well, we could do polynomial long division, or we could notice that what we're dividing by is a linear function. Let me go ahead and write that. It is linear, and the slope of that linear function is equal to 1. Check. So I'm going to go ahead and do synthetic division here again. So I'm going to start with my box, and this was an x plus 7. So we always put the opposite of that number in the box. That's going to be a minus 7. Okay, what comes after that, guys? All the coefficients of the original dividend. We've got x to the 4th, which has a coefficient of 1, and then a 6x cubed, so that's a 6. And I notice once again, there is no x squared term, so we've got to put a 0 there in the place of the x squared, followed by a positive 40x, and then a minus 33 at the end of all that. Skip a line and draw a line. And here we go, everybody. We begin by bringing the 1 straight down, and then we start multiplying. Negative 7 times that 1 there is going to give us negative 7, and we add these two terms together. 6 plus negative 7 is negative 1. Let's multiply again. Negative 7 times that negative 1 is positive 7, and we add these two together. 0 plus 7 is 7. Here we go. Let's keep multiplying. Negative 7 times positive 7 is negative 49. Let's add those terms together. 40 plus a negative 49 is going to be a negative 9. Negative 7, again here, times negative 9 is going to be a positive 63. And once more, we will add those as well here. And let's see what we got, guys. A negative 33 and a plus 63 is going to end up with a positive 30 here at the end. So that's as much as we needed to do. Now it's just time to put everything together. We began here with a 4th degree term. That means that our quotient begins with a 3rd degree term. So this would be 1x to the 3rd power. But of course, at this level, guys, it's silly to put the 1 right there. So we'll just make that x cubed. What comes next then? That is going to be a minus 1x squared. And again, you don't need the 1 there. Next term, we've got a plus 7, and I'm just going down the ladder. X cubed, x squared, so this is going to be x to the 1st. Then a minus 9, and this is our constant term. There would be no x right there. And finally, we end up with a positive 30 at the end. That term is your remainder, or at least the numerator of your remainder. So I'm going to put a 30 on top, and on the bottom, the x plus 7, and that, you guys, is our quotient to this rather messy division problem. Okay, so that's kind of a sense there, guys. I hope giving you a sense there for how synthetic division is going to work. Just want to remind you, it only works. Let's do this again. When the divisor is linear, such as x plus 7, and when the slope is equal to 1, which we had right here. But in other cases, synthetic division does not work. Okay, guys, I'm going to wrap this video up right here and then come back and talk about the remainder theorem in just a second. But I think that's probably a wrap for this one, and hopefully that should give you plenty to get started on your 5.4 homework. Good luck, everybody.